Ladies and gentlemen, I'm in front of you to present my communication. So I'm Gilles Nago. As already said, I'm from University of Parakou. University of Parakou is one of the fourth university of Benin, but the only one located in the northern parts of the country. So I'm coming from Parakou to present you climate change risk to marine ecosystem and fisheries. So the communication is about this outline of 9 points: introduction, primary climate change drivers affecting marine ecosystem, ecosystem level impact, some direct impact on fisheries, some regional cases, socioeconomic consequences, adaptation strategies, some mitigation approach, and conclusion. So we know that climate change poses significant risk to marine ecosystem and fisheries by threatening the livelihood of many millions of people that depend on this ecosystem for income, for cultural identity, but also for food. So we have the global ocean that experience physical and biochemical change due to anthropogenic climate change since the pre-industrial period. Ocean ecosystems are affected by climate change. So understanding the climate risk is critical for many millions of people of biodiversity, especially in West African countries. As primary climate change drivers affecting marine system, we will look at some factors from the historical data to the modeling of this data through two scenarios. We have the shared socioeconomic pathway 1 and the shared socioeconomic pathway 5. Here, we have the sea surface temperature, the first one. So when we look at the sea surface temperature, this is the old data, and this is the projected data. So we notice that there is a shift in the sea surface temperature compared to the old data. And between the two projections, we know that for the SSP5, we have a high temperature than for SSP1. Here we notice that there is a raise of temperature. So the temperature is more rising here than the first possibility. And here we have potential, hydrogen potential. For hydrogen potential, we notice that from historic data to the projection, we have an acidification of marine system. And this acidification is quite the same between the two scenarios. And here we have the dissolved oxygen. Also for the dissolved oxygen, we have less oxygen in the scenario of SSP5 than in scenario SSP1, but both show that we have less oxygen than the old data. We also have here the temperature, the marine system temperature. We compare this temperature between the two scenarios. There is quite no difference between the two scenarios, but there is a rise in temperature compared to the old data. Okay. So this rise of temperature is around 0.5 degrees Celsius. For nitrogen. For nitrogen, here you also remark that for nitrogen we have a shift compared to the old data, and for the SSP5. The SSP5 is the share socioeconomic pathway that use more fossil fuel than the SSP1, which is a sustainable projection. For the net primary production of the marine system, you also can see that this situation is better than this one, but when we compare to the old one, we remark that we have less primary production than we have ever. To resume, for temperature, independently to the different scenario, we remark that there is a rise of temperature. And also there is an acidification of marine ecosystem independently to the different projection. For dissolved oxygen also, we remark that there is less dissolved oxygen in marine system than we have in older data. These have some impact on ecosystem level. And here we want to point some aspect. Here you have the snow cover that decrease. We also have a glacier mass that decrease. And the permafrost temperature increase. We have here acidification of ocean and a decrease of dissolved oxygen of the ocean. This also, here also as ecosystem level impact, you can look here. There is a food web effect and a change of ocean salinity. Also, the stratification of the ocean also have impact due to climate change. So this change making fish stock distribution and abundance. Also, the spawning pattern and recruitment success of biodiversity are altered. Size and growth rates change in subcommercial species. We have increase of disease prevalence in wild stock, and we have economic implication for fishing community. Another socio-economic consequences of this is, we will see it, but we want to point some regional cases here. The first one is the tropical region. In tropical region, we remark that with climate change, we have coral reef fisheries collapse. And in polar region, already said, ice dynamic are changing, and in temperate region, we have species redistribution impact. And about species redistribution impact, I want to point seagrasses. We remark here that there is a reduction of temperate species like seagrasses. There is an increase of tropical species, and we could see here that we have crustacean and gasteropods that increase, and this is the so-called tropicalization of marine system, which is a recent global phenomenon in the ocean, resulting from climate change and characterized by the expansion of tropical and subtropical species toward the pole, and the retraction of temperate species. It is turned out that marine species in tropical region are moving poleward as tropical water become warm, and species from temperate region are declining, also due to the rising of ocean temperature. This has caused change in biodiversity of this ecosystem and could have consequence in global economy. So the consequence, the socio-economic consequence of this, we could list the price of basic foodstuff and consumer goods that rise. Fresh water will be short supply. We have some diseases, food insecurity, particularly for developing nations. We have economic impact on coastal communities and fishing industries. And we could also have some geopolitical tension over shifting fish stock. So there are some adaptation strategies, and here we can have a restoration of some habitat, we can have a resilience of some resources. We need also to manage things with people and community to let them change some activities, but also we also need building. But for all these adaptation strategies, we have to look at some indicators like an ecological indicators and socio-economic indicators to be sure that adaptation strategies are working. As mitigation approaches, we have some mitigation approaches listed here, like the reuse of things, the recycle, the purchase of energy efficient appliances, and drive less. We also have the reduce of use of chemical products, and so on. As a conclusion, it is imperative that we take immediate and collective action to mitigate impact of climate change on marine ecosystem and fisheries, ensuring future for our planet and also for our resources, focusing on some indicators. Here I point the ocean decade challenge. Some indicators here. We have the indicators 2, 3, 4, 5, 6, and 8. The indicators 2 is about the restoration, the protection of biodiversity. The indication 3 is about the sustainable use. The indicator 6 is about the increase of community resilience, coastal risk. I'm at the end of my communication, and I thank you for your attention.